All right, in this last section, we alluded to this earlier in previous practices where we were asked to take the second derivative. And the second derivative is just the derivative of the derivative. But we can continue going on and just take the third derivative, which is the derivative of the derivative. Um, or the derivative of the derivative, yes. And then continue on forever, right? Ad infinitum, as they would say. And so in this table, I just want to show you the symbols that we would use. So when we're finding the first derivative of y, we already know that we do either y prime or dy over dx. And when we do the first derivative of f, we do f prime of x. So the prime notation is our main notation, but not our only notation. And when we do the second derivative, we use two primes, or we say we're taking the second derivative of y with respect to x. And then when I do the second derivative of a function notation, we just say two primes. So the second derivative would be f double prime. We say f double prime or f triple prime. When we do the third derivative, that would be a triple prime, or we would say d3y over dx3. And in function notation, that would be the third derivative with three primes. But after that, we see no point in continuing and put four primes and five primes and six. Can you imagine taking the 10th derivative and having to write out 10 little prime symbols? So instead, what we say is we're taking the nth derivative at whatever n is, right? N could be 10, it could be 100, n could be 15. Whatever the nth derivative is, we kind of write it like an exponent, but in parentheses. So we say this is the nth derivative of y. Or we'll say dny over dxn, the nth derivative. Or we'll come over here and we'll say we're taking the nth derivative. Again, it kind of looks like a little exponent because there's a superscript, but put it in parentheses, and that's how we denote higher derivatives. So I can change this n to 10. I mean, I could even put a 3 here and say that's the third derivative instead of doing the triple prime notation. But this is how we show that we're trying to find derivatives, higher order derivatives, meaning multiple derivatives. We're taking multiple derivatives. And so when I look at number 4 here, we are taking, this is the second derivative, right? The second derivative. All right, so that means I'm going to have to take a derivative once and then take it again. So I need to find the first derivative. Well, here I have a chain rule situation because I have an inside function and an outside function. So I'm going to take the derivative of the outside with the inside still in it times the derivative of the inside. And the derivative of 4x is just 4. And I'm done. And I'm going to find the second derivative. That would be the derivative of that. So we're looking for this. That's the second derivative. Now I notice that I'm multiplying, and some people would say, well, you would use the product rule because you're multiplying. Except one of the things I'm multiplying is a constant. And we said constants are nice because we can always hold the constant and then take the derivative of the other thing and then multiply the constant back in. So I'm going to hold that 4, and I'm going to take the derivative of e to the 4x. Well, the derivative of e to the 4x means I'm taking a chain rule. So I'm going to take the derivative of the outside with the inside still in there times the derivative of the inside. And now I can combine the 4 times 4 and get 16e to the 4x. This is my second derivative, and this is what we were looking for. So higher order derivatives just means you're taking multiple derivatives of the same function. Whatever derivative I want is how many times I go, and then stop, right? Because that's all we're doing. We'll come back in the last video and finish up examples 5 and 6 to take us out of this unit 3.